Alright, so what you're looking at here is PeakAbu, a desktop application I'm building for gaming squads who want to capture, sync, and replay highlights from every player's perspective at the same time. The problem it solves is pretty simple. When something insane happens in a game, everyone on the squad has their own recording, but there's no way to watch all of them together synced up, like a proper replay. PeakAbu does exactly that. Every player records their own point of view locally, and when someone calls the highlight, all of those clips get packaged up and played back in a sync in a web player, switchable between perspectives on the fly. So, let's go ahead and walk us through here this whole thing from top to bottom, starting with the app itself. We got account creation right up here. When you first open up PeakAbu, you're going to land here. This is the account screen. You can log in if you already have an account or register a new one. No browser, no redirects, everything's handled natively here. When you create an account, your password is never stored in plain text on our end. It goes through bcrypt hashing, which is the industry standard for password storages, before it ever touches the server. And once you're logged in, the session is managed with a JWT token, a secure credential that gets saved locally on your machine so you don't have to log it back in every time you open up the app. That token is what identifies you to the server for everything else you do inside PeakAbu. So the tab layout here, once you're logged in, this is the main interface. It's broken up into a few tabs. You got your session tab. This is your hub. You either create a session or join one using the code. The person who creates the session is the host, and they control certain settings like how long the clips are. Everyone else joins with that same code. Then there's the start highlight session. This is where you configure and kick off your actual recording. You pick your monitor, set your frame rate, adjust resolution, and enable or disable mic capture. You also see your recording status here and the buffer indicator that tells you when there's actually enough footage buffered to save a highlight. So we can go ahead and show that off for a second here. You can see it's buffered. And after about 15 seconds, that'd be ready to play. So then lastly we have here is the... What's the settings tab? You have a settings tab up top here. Able to choose where you want to store your stuff. You're also able to configure your hotkeys as well. So all that's good to go for you. For everybody here, this is extra. Didn't mean to have this in here. Let's see. Okay, highlights tab. So, all right, recording, how capture works. All right, so here's where the magic actually starts, the recording engine. When you hit start recording, PeakAbu spins up an FFmpeg in the background. It's a professional grade video processing tool, and it's what handles the actual screen capture and encoding. For NVIDIA GPU users, we use NVNC, which is hardware accelerated encoding that runs entirely on your GPU. So there's essentially zero impact on your game performance. For AMD and Intel users, it fallbacks to a software encoder called libx264 automatically. No configuration needed. The capture runs in a rolling 3-minute buffer. So at any given moment, the last 3 minutes of your gameplay are sitting in memory, ready to be saved. The app writes these as 10-second video chunks in a temper folder in your background, constantly overwriting the oldest ones to stay within the buffer window. Mic audio is captured separately and buffered the same way, then merged into the final clip using the FFmpeg's audio mixing. Here's the other critical piece. When you first launch the app, PeakAbu quietly syncs your system clock to the NTP time server, a global time reference. This is how every player's clips get synchronized later, even across completely different machines. Everyone's timestamps are anchored to the same reference point. So, demonstrating a highlight here, saving a highlight. When something clip-worthy happens, you press the hotkey. It's F9 by default, but it's fully remappable. And that'll trigger a coordinated save across the entire session. Here's what that means, though. Your client sends a signal to the server. The server locks the session so no duplicate saves can fire, and then it broadcasts a coordinated timestamp back out to every player on the session simultaneously. Every client receives the same timestamp and uses it, along with their local NTP synced clock, to cut the clip to the exact same moment in time. So even though all 4 or 5 players are on completely different machines, they all save a clip that centers on the same real world moment. That's how the sync works. No manual alignment, no guesswork. So after the clip is saved locally, it automatically uploads to the server. The upload carries your username, the session code, and the coordinated timestamp, the shared time anchor. On the server side, that file gets handed off to the digital ocean spaces, which is a cloud object storage. It's also where a thumbnail gets generated from the clip automatically, so you get a preview image without having to load the video. Once the upload lands in cloud storage, it gets served through a CDN, a content delivery network. So when your squad goes to watch it, the video is being pulled from the edge servers close to them geographically, not from our dropper directly. That keeps the playback fast regardless of where everyone is. All right, so the web player itself. Kind of the big pot here. So this is what it actually looks like when everything comes together. This is a session from earlier for 3 buddies and I had. 3 perspectives, all captured simultaneously. The player pulls in all clips for this session and groups them by that coordinated timestamp, as I mentioned earlier. So you can see the clips from all 3 point of views right here, all aligned to the same moment. So, as you can see, there's also, it shows you like the list of highlights here and everything on the side. And if, if anything fails, it'll let you know if that person was able to upload a clip here. So we can just try this real quick. You see it's playing through. And you can control people's audios as well separately. So now we're actually watching one of audio capture now. Volume control as well, definitely needed. Okay. So as you can see, we got that action happening there. There's also a scrubbing feature, so you can always go back and play your videos when you need to. So it looks like Wonder got saved by somebody here. What happened? Keep playing it over and figure out what happened here. So, what was Cap doing at this time? If we play back, see what happened. He wasn't the one shooting. He was picking up loot. So, what was Neemian here doing? Click it to load it right up. Oh, look. He has a bow out for the ready. So what happened with him earlier? Oh, it was Neemian that saved Wonderful here. All right, so everyone gets to see what happened at all times. Excellent. All right. So as you can see, you can switch between players. Each one is their own independent video track. If someone's clip is still uploading when you open the player, it pulls in the background and loads it once it's ready. The timeline at the bottom lets you script through the highlights saved in this session. If there were multiple save events, you'd see them clustered here. You can see them through each one with the next and previous buttons. Just upload some videos here. Okay. So this all runs in a standard browser. No additional software needed to view. You just send a squad member the session link and they're in. So let's see. Backend server. All right, so this bit's a little bit more just the guts on how this program has been made and come together. So let's talk about what's happening under the hood to make all of this work reliably and keep it cost efficient. The server runs on a digital ocean droplet managed through PM2. That's a process manager that keeps the server alive, restarts it if it crashes, and handles logging. The server is built on Node.js with Express and Socket.io. Socket.io is what handles the real-time communication between clients for things like coordinated save signal and live recording status updates. Cloud storage lives in digital ocean spaces, which is S3 compatible object storage. After a clip uploads to the server, it immediately gets pushed to spaces and deleted from the droplet's local disk. So the server isn't accumulating gigabytes of video footage over time. The CDN layer on top of spaces means repeat views don't cost us extra origin bandwidth. They hit the cache. For storage efficiency, the server also runs clips through AV1 re-encoding after upload. AV1 is a modern codec that achieves roughly the same visual quality as the original at about 30 to 50% smaller file sizes. So your squad's 1080p clips come in as an H.264 file and goes back out as a much smaller AV1 file without a visible quality difference. On security, I brought that up earlier. And that's PeakAbu from top to bottom. The client, the capture engine, the sync system, the upload pipeline, the web player, and the backend that holds it all together. There's still a lot being built out, broader beta testing, tier-based access, AI highlight reels, but the core experience is working, and that's what you just saw. So there's much more to come, and I thank you very much for your time and watching the video.